So when you're talking about real-time data, two names pretty much always pop up: NATS and Kafka. And a lot of the time, they get pitted against each other, like they're just two competitors in the same race. But what if I told you that's kind of the wrong way to look at it? In this explainer, we're not going to get bogged down in benchmarks. Nope. Instead, we're going to dig into the fundamental design philosophies that make them tick, and why that matters way more than you might think. So, is this really just a vanilla versus chocolate situation? Are NATS and Kafka just two flavors of the same thing? Or are we actually comparing something totally different, like ice cream to a steak dinner? That's the core question we're going to answer today. And to do that, we have to start by looking at where these two incredible tools actually came from. Okay, so here's our game plan. We're going to break this down into 5 key parts. We'll kick things off with their origins. Then we'll look at how they find and store data, which is super different. After that, we'll look at the performance trade-offs that come from their designs. And finally, we'll get to the heart of it: how to choose the right tool for your specific problem. All right, first up, origins. To really get to the bottom of this, we have to go all the way back to the beginning. You see, their entire architecture, pretty much every design decision, stems from 2 completely different starting points. NATS was born as a pure messaging system. Seriously, think of it like a central nervous system for your applications. It was designed for ridiculously low latency, high fan-out, and flexible patterns like request-reply. Persistence, which we now know as JetStream, was an incredibly powerful layer that was added on top later. Kafka, on the other hand, was built from day one to be a distributed log. Its main job, its whole reason for being, is to act as an immutable, high-throughput ledger that can swallow and replay massive streams of events. And this, right here, is the foundational difference that everything else, and I mean everything, grows from. So that big difference in where they came from, it leads us directly into our next big point: how you actually find the specific data you're looking for inside a gigantic, rushing stream of information. NATS uses this really cool thing called subject-based addressing. Now, a subject isn't just a simple name or a label, it's a structured, hierarchical string. A great way to think about it is like a file path on your computer. And this structure is what makes it so powerful, because it lets you query your data right on the server. And this is where the magic really happens in the real world. You can subscribe to something super specific, like a single order ID. Or by using wildcards, you can get much, much broader. That little asterisk acts as a single-level wildcard. So orders.us.star gets you every single order in the US. And see that greater than symbol? That's a multi-level wildcard, grabbing everything that comes after it. This gives you incredibly efficient server-side filtering. It's almost like having an index in a database. The server finds exactly what you asked for and only sends you that. Okay, so let's flip over to Kafka. In Kafka, you also have something called a key, but its main purpose is totally different. It's not really for looking up data. The key gets hashed to decide which partition, which slice of a topic that message is going to be written to. This is super important because it guarantees that all messages with the same key, like from the same user ID, always land in the same partition, which keeps them in order. But again, it's not a query tool. So that begs the question, right? If the key is just for routing, how in the world do you filter for specific data? How do you get just the stock ticks for Microsoft, for example, without having to create a totally separate topic for every single stock symbol? Well, the answer is, with Kafka, that filtering happens on the client side. It's on you. As you can see here, the broker just sends the entire fire hose of data from a partition straight over the network. Your application then has to receive every single message, look at its key or its payload, and then just throw away all the ones it doesn't care about. You can probably imagine how inefficient this can be, especially if you only need a tiny fraction of the data in a really high-volume topic. And this philosophical split just keeps going, right down to the storage layer. How each of these systems physically stores and manages your data is just fundamentally different. Like we've been saying, Kafka is a distributed log. That means it's append-only. New messages get tacked on to the end. Old messages can be trimmed off the beginning, maybe based on time or size. But what you cannot do is reach into the middle of that log and just pluck out a specific individual message. It's designed to be an immutable record of exactly what happened, set in stone. This quote from one of the core NATS engineers really just nails it. NATS JetStream acts much more like a flexible data store. It's not just a pipe designed to spit messages out, it's a system you can interact with in much more complex and granular ways. Let's break that down with a direct side-by-side comparison. Looking at this table, you can see right away with JetStream, you can delete individual messages, you can set limits on a per-subject basis, like, hey, only keep the last 5 messages for this specific sensor. You can do true updates with concurrency control. You can even tell a stream to reject new writes when it hits a limit, which is absolutely crucial for things like distributed locking. Kafka's model, by contrast, is much simpler. Just write and maybe compact it later.
So all of these design choices, messaging versus log, subject versus key, data store versus log, they all lead to very, very different performance characteristics. And this is where we get to the core trade-off between them.
NATS is built for speed, specifically in terms of latency. Individual operations are often measured in microseconds. It's all about near real-time communication. Kafka, on the other hand, is optimized for maximum raw throughput. It gets this incredible throughput by batching messages together, which is super efficient for writing massive amounts of data. But it introduces latency. Its operations are typically measured in milliseconds. Now, neither of these is better. They're just optimized for completely different goals. So let's put that into perspective. If you're building, say, a command and control system for IoT devices where every microsecond counts, or maybe a trading platform that needs to flexibly query different streams of market data, NATS is going to feel like a natural fit. But if your goal is to build a data lake ingesting terabytes of user activity logs for analysis later on, Kafka's high-throughput architecture is a proven, absolute powerhouse for that job. And that brings us right to the final, most important takeaway. It's not about which tool is faster or better. It's about which tool was designed to solve the problem that you actually have. So, to wrap it all up, think of them this way. NATS with JetStream is a versatile, real-time system that gives you really fine-grained control over your data. It's almost like a database and a messaging system had a baby. Apache Kafka is a purpose-built, massively scalable platform for processing logs. It's a fire hose designed to never, ever drop a single drop of data.
So when you're making your choice, the question to ask isn't which one is better. It's what am I building? Are you building a reactive, fast, and intelligent nervous system that needs to query and react to events in real time? Or are you building a massive, durable archive designed to record history at an incredible scale? The answer to that question, well, that's going to tell you everything you need to know.